Good morning, good afternoon, everybody, depending on where you are. I'm Stuart Gillis. I'm the operations manager for ABL Rig Inspections. And the agenda for today is really, we've had the introduction from Peter. Want to talk about the issues associated with obsolescence in drilling equipment. Look at some findings and examples from drilling equipment, which will be presented by Amit. Look at how the obsolescence affects and impacts drilling operations, and then discuss how to, well, not necessarily how to, but the issues associated with managing obsolescence within drilling equipment. At the end of this, we intend to have some form of open discussion where we can discuss the issues that various people are experiencing and see what ideas we can come up with to address them as some sort of forum. So to that end, the ABL rig inspection team is headquartered in four locations globally. We have in our Houston office Ryan Bridge, who's the rig inspection manager for there. In the UK, we have a team in 3 or 4 locations to conduct rig inspections. We have an office in Algeria, which looks after the Middle Eastern regions, and we have the KL and Singapore offices, which look after the Asia Pacific regions. So we have global reach for rig inspection, and we conduct rig inspections globally. The rig inspection team is headed up by the Group Director of Critical Systems, Stephen Lee, and he's responsible for rig inspection and for dynamic positioning system inspections. Supporting him in rig inspection, there's myself as the operations manager, and we also have Richard Brennan, who is well control equipment manager. In the business development sector, we have Peter Hone, and supporting engineering projects with Michelle Lee, who's based in Newcastle. Looking at the regional managers, we have Amit Kulkarni, who's Asia Pacific regional manager. We have Ryan Bridge, who's based in Houston, and he's the Americas regional manager, looking after both North and South America. At the moment, looking after the Middle Eastern regions, Europe and Africa, is Martin Clark, who's based in Aberdeen in the UK. Working with the regional managers, we have basically global subject matter experts who look after the particular disciplines as subject matter experts. Starting on the left of the little organogram shown there, electrical and controls. We also have, working within that, the software and cybersecurity subject matter experts. For DP, we also have DP, marine and mechanical subject matter experts. HSEQ, looking after the safety, environmental aspects, and also well control, which we've discussed, which is run under Richard Brennan as the well control equipment manager. When we look at the rig inspection teams that we send on jobs, we have staff inspection team leaders who head up the actual inspections on the ground or on the vessel, and they're supported by inspection teams comprising the mechanical, electrical control systems, HSE disciplines that we require for those particular jobs. And they can comprise mainly staff when we have them, but they can be supplemented by freelancers where required. So the issues. Obsolescence. When I was asked about what are the issues affecting rig inspections today, one of the recurring themes that kept coming up was obsolescence of equipment. So we decided that this webinar should focus on that as a major issue which is arising from rig inspections. And when you look at obsolescence, I think everybody in the modern world understands or has a fundamental sort of like idea of what obsolescence is to them and how it affects their lives on a day-to-day basis. So, for example, you get a phone, and then you want to upgrade it to put a new app on it, and you suddenly find that your app doesn't work or load on your phone because the software in your phone is obsolete. So that's an everyday frustration associated with it. I think lots of people have got equipment in their sheds and garages which they can't fix because they can't get spares for them. This is another function of obsolescence and how it manifests itself on a day-to-day basis. Various people, including myself, have got lots of old equipment lying around the house which you can't use anymore. And when you try and upgrade things, you've got a never-ending cycle of increasing technology which you have to deal with. So I think those are everybody's sort of like personal experiences of obsolescence on a day-to-day basis. When you start to look at obsolescence as a process or a managerial process or an academic topic or however you want to look at it, you find that there is various documentation and management assistance out there to help you. The IEC 62404-2, which was written in 2019, actually defines obsolescence as the transition of an item from available to unavailable from the manufacturer in accordance with original specification, which is a bit of a mouthful, but it kind of sums up how the IEC sees obsolescence in terms of a definition. But when you start to look at it in the broader picture of what is obsolescence, and you start to look at academic papers written on the topic, you find that the definition starts to become a bit wider. And it starts off when a product no longer meets the required capability, i.e. that there's a capability gap. But what defines that capability gap is the common question. So they define it, well, they state that the capability gap consists of two main parts. The first part being functional obsolescence. And functional obsolescence is when the product or the subsystem is operating as intended and can still be produced and supported, but the requirements have increased. And that might lead into the example provided by the mobile phone, where you have a mobile phone, the mobile phone still works, but you want to upgrade it. Well, you want to insert an app which needs an upgraded operating system. So your phone still has its same functional capability, but it doesn't meet the requirement that you're now placing on it. The second way of looking at obsolescence is the logistical obsolescence. And this falls back more in line with the IEC's definition, in that a material or technology which is needed to manufacture or support a product or system is not available from existing stock or from the OEM. And this is basically when you start to run out of spares or you don't get OEM support for a particular piece of equipment, which means that there's gaps in the support for that equipment, either materially in terms of parts or in terms of servicing and spares or software from that original equipment manufacturer. So looking at how a product and how this equates to a product, typically when a product is made, there will be some sort of requirement or desired capability which sets the basis for that product to be produced. The product is then manufactured and brought into service, and whilst it's in service, it gets some sort of support from the OEM, and that's effectively the logistical support. Over time, what you'll find is that as per your mobile phone, the requirement of that piece of equipment will start to increase. And as the requirement starts to increase, or the desired functionality starts to increase, then you start to see a gap emerging here between your desired capability and your actual capability of what the equipment can actually produce. There's further developments when it looks like the OEM is going to move on to the next product that they're developing. So the OEM support for that particular piece of equipment or product starts to decay, which also would lead to a decline in that product's capability because of its sustainability, if you like. As that approaches its end of life phase for that particular product, then that logistical support has a greater effect on the product capability or the support of that product. And these various stages can be defined as the logistical gap, which was the second capability gap, and functional gap, which was the first capability gap that we discussed. And when you look at those things combined as per the definitions, then we effectively start to see that we have an obsolescence gap here, which can be manageable or tolerable up to a certain point. And then at some point, the capability of the equipment falls off sufficiently that it becomes an intolerable obsolescence gap, and it means that the product can no longer be supported. So that's taking into account a single product. But the problem when you're dealing with something as big as a drilling rig or a drill ship is that you have multi-level challenges. And this is where the drill ship or the drilling rig has a long life cycle, but the internal components or the equipment on board and the subcomponents and the software have different life cycles. And because they have different life cycles, it means that you have different speeds at which things become obsolescence. And the management of this obsolescence then becomes a very complex management issue to assess, risk assess, and ultimately try and put into place some structure that you can use to manage this particular problem. So why have we got obsolescence? Or why is it such a big issue at the moment regarding rig inspection? In many cases, it comes back to the age of the equipment and the time at which these technologies were built and developed, and where technology has got to in the present day. So the average age of a drill ship is 12 years. The average age of a jackup and semi-sub is 21 years. These are taken from SGN statistics. There was a large offshore rig building program in the period between 2004 and 2014, which put a lot of rigs into service, but there have been few new orders since 2015, although rigs have been brought into service since that time, which have been from effectively stacked new builds. So when I took the statistics on years that rigs had been built, I put them into a graph to try and get some sort of picture of where these ages were actually sort of like falling, because the average wasn't kind of making entire sense to me. And what it worked out as that 2004 to 2014 build period was in the most recent sort of like boom, if you like, in rig building. And that puts all your rigs in this 10 to 20 year section here. And that'll be all your new generation 6 and 7 drill ships, semi-subs, jackups. When you look at the 25 to 35 year window, which is in this particular section here, you can see that there's virtually no semi-subs. The jackup numbers have gone really low, and there are no drill ships in that particular period. And I think this matches quite well with the generation 4 and 5 automation, which started to be developed in the late 80s, early 90s. And a lot of these rigs have become, in effect, obsolete and difficult to upgrade, and therefore they've been taken out of service. The rigs which are in service are at the far end of the graph here, where you see there's a peak in jackups, and that equates to the manual jackups and semi-subs, which have virtually no automation on them or very limited automation. So there's quite a distinct sort of like area to be learned from that section of analysis. So the other issues that are associated with that are not just the actual rig build, it's to do with the market forces affecting rig operations. So in 2014, there was a rapid downturn in oil price. Then we had a further downturn during the pandemic, and this led to multiple rigs being stacked for protracted periods of time. So whilst the rig's stacked, it's not making any money, but the march of time is continuing, and therefore the obsolescence issues are still developing. So as the obsolescence becomes embedded in the equipment that you've got, and you don't have any funds to upgrade or support the obsolescence issues which are arising, when it comes to the resumption of service and putting the rigs back into operation, then you find that you have a deficit both of funds and you have a deficit of equipment capability due to the obsolescence which has arisen from these particular sets of circumstances. So that's why when we're conducting rig inspections at the moment, we're finding that in the types of rigs that we're inspecting and the operational status that they've had over the past few years, that the obsolescence becomes a significant issue. So I'll hand over to Amit Kulkarni, who'll run through some of the typical findings that we have of obsolescence from drilling rigs. Amit.
Thank you, Stuart. Hello, everyone. Can we go on the next slide, Stuart, please? Yeah, here are some of the common findings that we come across during our rig inspections. The first one, as you can see there, is a switch, a network switch that has an issue of overload, which is been obsolete since August 2017. Now, this switch is mostly installed on the remote diagnostic systems on the rigs, and we see that this is still being used despite it's being obsolete. The next one that you see on there is a Siemens S7300. I mean, there are rigs where I have seen S7200 being used as well, which is obsolete again, and S7300, which is widely used across the industry, is going to be obsolete next year, October. So, which is considered to be phased out as of now since last year, and they say Siemens basically say that their spare parts will still be available for next 10 years, but they won't be selling it as a whole or manufacturing it anymore, which means the OEM will advise on an alternative on this. We haven't heard from any of the major OEMs yet on what they're going to do about it, but very soon we can expect something from their side. Can we go to the next one, please? So you can see here RigSense system, the main server on a couple of the rigs that I've seen had the anti-malware expired. They were running it on a Windows XP operating system with open USBs, and it was still on the network, which increases cyber threats and vulnerabilities to have a cyber attack, basically. The next one that you see on there is an encoder that is installed on the top drive, 8SA mainly, of NOV. That part has been obsolete, but was found in stores on a couple of the rigs that we've been to. And the next one that you see on there is a Autronica panel, which is used for fire and gas, and that has been declared as obsolete by the OEM, but we see several of the rigs still using BS320 control panels, and they have not been upgraded yet to the BS420 as what the OEM recommends it to be replaced with. One of the common software or operating systems that we have seen is Windows XP, that has been used on several of the control systems on the rigs, which has been obsolete since 2014. And this has been in multiple control systems like the drilling, well control, and so on. And the last one that you see on there is a server by Acre. This has been obsolete as well and has been found on several of the rigs that we have inspected. Can we go on the next one? Yeah. So if you can see the stats based on the findings that we have had since last 3 years, we see that 25% of the findings related to obsolescence came from the drilling equipment. So overall findings that we have on drilling equipment, 25% of them are related to obsolescence, if I can put it that way. So we also see that there are obsolescence related findings on marine equipment and the software. And the last one is the spares management, which means we have seen several of them which are pertaining to spares, like which totally it sums up to 65%. But what we also have seen is there are so many spares in the warehouse which was seen to be obsolete. So it wasn't used on the equipment operating, but were reserved as spares. So something that we would like to highlight here. Can we go on the next one, please?
Yeah.
Yeah, okay, so that's it. So I'll hand it over back to Stuart.
Yeah, I think the points that Amit make in terms of the actual equipment findings are well made and very valid. I think in the bigger picture, looking at obsolescence, the main finding, or one of the findings, would be that drilling contractors have reactive obsolescence management planning. And how that manifests itself is that the basic method of managing obsolescence is to continue with their current planned maintenance systems, identify obsolete components as they arise, and then procure the spares that they need to support operations for as long as they can support them with those particular pieces of equipment. And that's entirely understandable and justifiable considering the economic climate that they've just emerged from. But what does that result in? Well, it means that operating systems beyond their OEM-defined life results in reduced OEM support. And that manifests itself in different ways. That you have difficulty in procurement of spare parts as the primary one. There are certain components which you can identify, which there are plug-and-play replacements, and they can basically be plugged straight in, and there's not necessarily any issues associated with that. You may find that there's some components which are supposedly plug and play and they function electronically, but you require to modify cabinets due to the mechanical makeup of the actual components themselves, or miniaturization. You may find that some of them have the correct hardware, but they have incompatible firmware or software versions fitted to the replacement components, which makes it difficult to incorporate them into the systems that are being used. And as a result of this, we sometimes find non-OEM components being fitted to safety critical systems. In addition to that, the support from the OEM often leads to problems associated with software compatibility. So if you have an operating system such as the Windows XP system, you may find that if the OEM has moved on from operating systems that they operate with and support, then there's difficulty in implementing upgrades to the equipment to interface with those particular operating systems. So complex interfaces, and it also means that those interfaces become difficult to maintain because they're kind of unique to those particular upgrades to those specific systems. It's a little bit of a big picture to try and present there, but hopefully that's got the message across. So looking at the effects and impacts, short term, if you have a reactive plan, then you end up with effectively obsolete hardware and possibly software. You're likely to end up with a dwindling spare stock, which makes it more difficult to support the equipment. You will have an effect, which is an increase in downtime, because the older equipment has the likelihood of failing more frequently, and it may be for longer periods because of the difficulties in acquiring spares or getting the spares. Because the OEM is progressively less able to support the rig or vessel, then the spares becomes difficult. The maintenance plans become difficult to upkeep, and upgrades to the equipment on board become more difficult to implement. And as Amit already pointed out, there's an increase in the likelihood of cyber threats because, for example, the Juniper firewall has known vulnerabilities. XP operating systems have known cyber vulnerabilities, and these need to be taken into account as a risk factor. So from the previous graphs, what you can see from this one, on the purple line at the bottom is non-productive time. So non-productive time goes down initially as teething problems are solved when equipment's brought into service. There's then a sort of like stable function where you're supported by the OEM. And then as OEM support starts to decline, then you can end up with gradually increasing non-productive time. when you get into the unacceptable obsolescence phase, then non-productive time can increase exponentially. So the long-term effects really of that obsolescence plan is you have an impaired ability to maintain the system. You start to get significant increases in downtime. The OEM is less likely or unable to provide support. It becomes not viable to upgrade the systems because the number of systems that you have to upgrade, the longer that you leave it, the more expensive it becomes. And that eventually leads to a place where you're unable to continue operations with that particular rig. And that leads to an early retirement of the rig, as we saw with the generation 4 and 5 rigs from the previous slides. So in terms of managing obsolescence, it's I think we've highlighted there that it's a fairly complex operation based on the number of factors that are involved in it. And therefore you need some sort of obsolescence management strategy. So the question which arose is, what is an obsolescence management strategy? And it's broadly defined as a strategy that seeks to gain an understanding of the risks of obsolescence and to provide a framework to support the obsolescence risk assessment and aid in decision making. It isn't a tool to tell you what exactly to do. It's just a method of making assessment of risks and making decisions based on those risks that you've identified. So in order to make an obsolescence management strategy, you need to have an understanding of the obsolescence landscape that you're operating within and the challenges associated with that obsolescence landscape, because there's significant factors there that will come to play. And if you don't understand that, then you'll have difficulties in implementing an optimal obsolescence management strategy. And that's just taken from an academic paper. So we said earlier that the obsolescence management, obsolescence is in two parts, which is the capability gap. So functional obsolescence, where the product is still operating as intended and can still be produced and supported, but the requirements are increased. There's limited management options available for equipment owners to address that because they have no control over the requirements that have been placed unless they've decided to take on that particular requirement. But in that case, then the only real option is to upgrade. So there's limited management options available in that. In terms of logistical obsolescence, where the material or technology to support the product is not available from existing stock or OEM, then there are things that you can do to address this by effectively forward planning. And basically, there's multiple management options available to equipment owners to support logistical obsolescence or to manage logistical obsolescence. So in terms of the management of obsolescence, there's different levels going from the reactive to the proactive. And these are broadly defined as the least reactive, which is to deal with obsolescence as they arise reactively. And if you do that too late, then you'll miss the last time buy notifications for the spares that you require to keep the equipment going. The next one level up from that is basically where you're reactive, but you have enough intelligence to make the last time buy to avoid or solve the obsolescence issues that you have identified to take that forward. The sort of like normal, more medium proactive management level is where obsolescence managers are employed to use obsolescence monitoring tools, notify obsolescence issues proactively to the management of the company, and enable them to decide on the key parts that should be managed proactively to enable that smooth management of obsolescence and hopefully provide the spares to keep equipment going for as long as possible in a sustainable manner. When we get to level 4, then we're looking at the proactive measures that can be taken to address obsolescence. And these are considering them at the design stage getting into partnering agreements with suppliers, and using technology road mapping to identify what equipment is going to likely be obsolescent in the near or longer terms. And at level 5, you do everything as per level 4, but you look at the options of multi-source components, whether you can get them from different suppliers, and you employ technologies which are less likely to become obsolete. So when should you employ these strategies? This shows the various phases phases of life, if you like, from a rig's perspective. So from the point of view of design and engineering, if you look at level 4 in the proactive section here, it says consider obsolescence at the design stage, and use technologies that are less likely to become obsolete, and look at multi-source components. So those are the typical things that you could look at there. In terms of the next stage, which is the procurement stage up here, then going back to this, then considering all of the above, but partnering agreements with suppliers are a good thing to consider. And the other thing is, in terms of procurement, you shouldn't necessarily look at the acquisition of the cheapest equipment to build your rig or vessel. You should look at the through life costs and see how that equipment can be supported through life, and what the likely obsolescence issues arising from that are likely to be. In terms of operations, the operations typically lie in the level 3 region, looking at obsolescence managers to keep monitoring what's going on, notify the issues proactively to management, and deciding on the parts that should be managed proactively. Maintenance and overhauls, I think that's a combination of 3, 4, and 5. And when you get back to things like reactivation, it depends on how your reactivation is going to be conducted. If your reactivation is going to be conducted with a view to extending the life, it becomes a combination of life extension and reactivation, which comes back to the design and engineering phase and the procurement phases combined together. If it's going to be a case of just getting the vessel out of the yard, then you look at the reactivation plan and considering how long that you think that you need this rig to be operating for. So in the basic terms, and this is taken effectively from the IEC, you should establish a proactive approach where possible. You can conduct regular component life cycle assessments to see where they fit in the obsolescence stage. Develop contingency plans when you've identified the risks. Collaborate with suppliers and partners in your management of the equipment, and continuously monitor and review the obsolescence risks associated with the various types of equipment and software that you have in service. And now pass you over to Peter Adam again, who'll talk about how rig inspection and asset integrity can tie together.
Thank you, Stuart. So we've been looking there at how the rig inspection team have been inspecting rigs and vessels over the years, and finding the issues and raising the challenge here. So we want to look at how asset integrity can help with that on the strategy, the plan, execute, report, and analyze, improve cycle throughout the rest of the life cycle of the asset. Next slide, please, Stuart. So we don't want to be doing the same thing over and over again. We don't want to be performing the rig inspection and finding the same issues sit there, and the same risks and threats are sitting there, potentially causing high mean time to repairs on the rigs or vessels. So we want to move to that more proactive approach, like Stuart was talking about, where we're doing the act and plan element of the review and improve cycle. And within that, we can use asset integrity to look at the strategy, the plan, the execution and report and analysis of the obsolescence of equipment on an asset. Next slide, please, Stuart. So The main tactics that we can deploy to help us support obsolescence of an asset is to look at the asset lifecycle management. So with that, we want to understand asset planning and map out what is the expected life cycle of that asset remaining. What are the equipment risks on there and critical equipment, taking into account potential obsolescence risk through that life cycle period. Obsolescence monitoring, so monitoring a database of spare parts and materials and technology that might become obsolescence within that remaining life cycle. And this can include vendor announcement and industry trends as well. We also want to look at predictive maintenance, so leveraging technologies like condition monitoring, IoT sensors, and machine learning to look at when equipment is likely to fail again, and is that within the remaining life cycle of the equipment and the asset. We want to look at the obsolescence risk assessment as well, so performing criticality analysis to look at assets which are critical, pieces of equipment that are critical within it. We want to look at the failure modes effect analysis of the equipment within there as well. So what is the impact of that on safety, operations, or cost if that piece of equipment fails? And is there interchangeability as well? We want to look at vulnerability analysis within obsolescence risk assessment as well. So which assets are becoming obsolete based on age, the manufacturer's planned, and the rapid evolution of technology. We need to make data-driven decisions as well. So this means analyzing the data we have available to track parts and spares availability, continuously monitoring the available of replacement spares, especially when a vendor announces the phase out of components. We want to look at that condition monitoring to look at the failure risks before they become a critical issue. And we want to forecast obsolescence as well. So using historical data and trends to predict when equipment will likely become obsolete or fail, allowing us to plan for this. We need to look at life cycle extension strategies. So repurposing or upgrading the equipment we have. That's something that we've looked at across cranes, for example, where additional 5 years was added to the life cycle of an asset, and we had to look at the upgrade of the components of the cranes required to extend the life of that for another 5 years, for example. And that helps you manage the operational life of that equipment, look at the maintenance costs of it and the efficiency and availability of it through the remaining life cycle. We want to look at an obsolescence management program, so looking at how we manage and mitigate obsolescence risks, and looking at the failure rate and likelihood of failure and what the impact on the repair time and turnaround is on the equipment as a result. We want to look at engineering modifications as well to decide if we need to make older equipment able to meet modern performance and safety standards as well. So as Stuart was talking about, the requirements on the equipment can change over time, and will the equipment we have keep pace with that? We have to look at supplier relationship management as well. So what contracts we have in place with vendors to stay informed about discontinued notices of products. We need to look at what the like-for-like replaceable items are there, and within our maintenance systems, look at whether we hold the equipment specification rather than a specific model manufacturer that can be changed out with a like-for-like, for example. We need to look at second sourcing and stockpiling, so where there are critical equipment and there are still spares on the market, but they're going to become unavailable, what levels of inventory and components are we going to need to keep of those, and how do we look at maintaining them while they're in storage as well? We need to do supplier evaluation as well, so regularly evaluating the suppliers and their ability to provide long-term support, as suppliers can go out of business or be bought over by other companies, which will then change their strategy as to how they manufacture equipment and spares. We also need to look at future regulatory and compliance considerations as well, which may make our equipment redundant based on maybe the gases involved in those pieces of equipment. So there may be safety regulations, or there may be environmental regulations that will make equipment redundant much more quickly than we had planned. So we need to look at the impact of changes in regulations and compliance and their impact in accelerating the decline of an obsolescence of equipment. So these are just some of the ways that we can look at dealing with it and tactics for obsolescence, and certainly things that we'll be discussing further in the future. Next slide, please.
Okay, do you want me to do this one?
Yes, please, Stuart.
Yeah, so I think, in Peter's run through of the things that need to be considered, I think it's well encapsulated in this final slide regarding establishing a proactive approach, and that's across a lot of different disciplines and a lot of different considerations, and thinking ahead and how that's going to be done. Conducting regular life cycle assessments of the equipment that you do have in service, the contingency planning that goes into that, which again was nicely summarised by Peter, how to collaborate with suppliers and partners to make sure that you're getting the best support from them, both in terms of the provision of support and spares and obsolescence upgrade information, and how they're going to how the manufacturers are getting involved in this obsolescence issue with you, and continuously monitoring and review obsolescence risks, and having some sort of mechanism for ranking them and grading them, and a lot of details on that are provided within the various IECs and obsolescence management documentation that's freely available or widely available. So that pretty much brings us to the end of the formal part of the webinar, and happy to take some questions as they've arisen throughout the presentation.
Thank you, Stuart. We have a few questions, and please put your questions into the question section of the Zoom app. I'll kick off with some questions for the team here. So obsolescent equipment can still work for many years, and in some cases still does. What are the problems with running equipment further on in life?
I'll start with that one. I agree that, and that's what we highlighted during the actual webinar, is that it's a frequent finding of the inspections that we conduct, that we do identify obsolete equipment, and that obsolete equipment is still actually working and functional, and therefore it depends on the equipment owner, how they are managing the operation of that obsolete equipment which we've identified on board. So it may well be that the equipment owner does in fact already have a stockpile of spares, so even though the equipment is out of date, they can still support it. But I think that operation of obsolete equipment should still be supported by some form of risk assessment from the equipment owner, to make sure that they understand, firstly, probably the criticality of that component. So Amit pointed out, for example, that fire and gas system. So that's a critical component. If that goes down and you don't have any spares, then you're going to be pulling the place that could put the rig out of operation. But if the vessel owner has a spare Autronica system which is still obsolete but functional, and they can replace it fairly quickly, then the risks are minimized from that. So my take on it would be, yes, it is possible, but you need to understand what the equipment owner has put in place to support the operation of that, and that they have an understanding of the criticality of the equipment that they're intending to run on as obsolete.
Yeah, so it's the mitigations there, and if there's been stockpiling of spares or some other contingency in place, isn't it?
Yeah.
Another question here, I think this might be for you, Amit. So Siemens S7300 PLC controllers are the industry standard for automation. How long will they be supported for?
S7300, as they mention on the website, it's still not obsolete, so it will be obsolete only in October 2025. So after that, there will be spare parts available until 10 years, which means 2033. Um, it will be when Siemens stops manufacturing the spares completely. But again, as I mentioned, it would be worth waiting to see what the OEM decides on this, whether they recommend upgrading the system for S7 1500, which is the latest version, or they would want to bring in a different PLC in place, or how they would manage the risk. So it would be worthwhile asking or waiting on OEM to come back on what their take is going to be on this obsolescence of S7300.
Thanks, Amit. Question here. If an item of equipment has stated design specifications, so it'll have a useful or safe life at the basis of design stage, I guess, why does the capability rise on the graph? The design spec is the design spec.
Yeah, I think I was talking about right at the start when I put on the graph which showed the required capability and the actual capability of the equipment, and also showed the OEM support for that particular piece of equipment. The reason that I put an increase in capability on that is based on the fact that when a piece of equipment, and I was thinking here about rig equipment supported by rig equipment manufacturers, and normally as the product goes through its life, there are product bulletins and there are product upgrades which are put on offer to be implemented by the OEM to support that. And if these upgrades are implemented, then in my mind, when I was producing that slide, that leads to an increase in capability, sustainability, or supportability of that particular bit of equipment. So that's why the graph was like that. It wasn't basically designed around the functional design spec of when it was manufactured and kept as a constant.
Thanks, Stuart. I think this next question here is kind of like a circular economy question. So during the downturn, a number of rigs were scrapped. Why did the owners not scavenge components from these rigs and use them as fleet spares?
It's a good point. Amit, have you got any take on that?
No, I think they have done that. Particularly, we've seen a lot of companies stealing parts from this rig and installing in that rig, and so that was my point.
So I think maybe that sounds like it's more of a reactive approach to, kind of cannibalizing rigs that are stood down for rigs that are active, for example, which is maybe not the best approach because it's maybe still cold stacked and you don't know whether it's going to be reactivated again at that point or not. So I guess it's not quite the proactive approach that we were hoping for, and maybe more of a cannibalization.
I think it depends on what the rig owner's intention was when they scrapped the rig. Was the rig owner's intention to get out of the drilling game for that particular period, or was the rig owner's intention to reduce the fleet size but support another part of the fleet? In which case, if you have similar types of rigs, if you've got three or four identical rigs, then it may well you can't afford to support four, but you can afford to support two, in which case the cannibalization thing would have been a good idea, but whether it's conducted or not is entirely up to the drilling contractor or the rig owner.
I think the other thing that we see there that can be a challenge is you can have the good intent of doing that, but if you don't store the equipment properly, have the right preservation maintenance in place, take it off the asset in the right way in the first place, and potentially flush it or do whatever you need to do with it, then those spare parts can actually be scrap at that point anyway, because they haven't been cared for or removed correctly and then cared for once they are in, and they may need to be recertified as well. So that also presents challenges. So I think if there's a good, clear strategy for it, and that execution of it can be a good way to have that circular economy and bring equipment back into legacy assets. But it has to be done in the right way, I guess.
Yeah.
Another question here: what strategies can be implemented to manage the obsolescence of critical drilling equipment, such as top drives, mud pumps, whilst ensuring operational continuity and compliance and evolving industry standards?
Yeah, there's a lot of bits to that question. I think the first one, when you're saying about compliance with industry standards, is that you would need to know what the industry standards were that you're going to try and comply with, and do some sort of research on that. Regarding upgrades of top drives and mud pumps, then I think that comes back to some of the fundamentals that we talked about in the webinar, which is maintaining relationships with the OEMs and the suppliers, such that you know what upgrades and obsolescence items are going to be issues for you. The other thing about it is, when you're putting into place upgrades to equipment, you've got to identify a time frame where you're going to do that, because effectively the rig is supposed to be in service and drilling and making money, and you're taking it out of service to implement these upgrades. So they should be scheduled with their sort of like major maintenance programs or SPSs and 5-yearly overhauls and that type of thing. And the other part which ties up with that is financial planning. Where's the money coming from to embody these upgrades that you might have envisaged? So there's a whole load of things I think that need to be considered when you start to look at upgrades and how you're going to support or upgrade massive pieces of equipment with very large capital outlay.
Okay. Anything else to add to that, Amit? I think thinking about when you're doing the major upgrades or major overhauls and trying to fit those together and plan as part of that to have a look at obsolescence as almost a regular activity, I think would be a good idea, wouldn't it? Because I think it just creeps up on you. You're busy with operating and maintaining and commercial aspects of a rig, and then this aspect of obsolescence kind of creeps up on you over time, doesn't it? So I think you have to build in those kind of milestones where you're going to look at critical equipment and your strategy, and is it the right strategy for the next 5 years, for example?
Yeah, absolutely.
There's one final question here. Is there a knock-on effect for operators when obsolescence of parts is concerned?
Say that again. Is
there a knock-on effect for operators where obsolescence of parts is concerned?
Does it affect the operator? Well, it does, because the operator ultimately is taken on the rig to perform a task, and the effect of any downtime will have an effect on the cost versus efficiency of taking on that rig. So the knock on to the operator is that if you have obsolescence involved in the rig that you're taking on, then you run the risk of increasing downtime, but potentially exponential risk of increasing downtime if an OEM stops support of critical systems on board the rig. So yeah, it does, in my opinion, and it's quite a significant one. I think I didn't quite understand the question at the start.
Yeah,
thinking about the question where that's driving from is actually quite a big impact. Yeah.
It's a big commercial impact, isn't it, as well? It's a reputational impact as well. So, you know, if you have a lot of downtime because of lead time on a obsolete spare, that reputationally will impact your relationship with that IOC, for example, or operator. We've seen operators ask specifically for critical spares strategy for in the drilling company, as part of the asset integrity management team, and them wanting to see demonstration that critical spares are available for the duration of the operations. So again, that can limit what contracts you can win even as well, I think, potentially. If you've got an aging facility, then demonstrating how you're managing that will become more key. As the asset's older, the operator will see that more and more as a risk, I guess, as to satisfactory operations for the period where they're contracting that rig, for example.
Just want to add a point there regarding safety as well. So when it comes to some of the obsolescent parts or obsolete parts, there is also a safety factor that is to be considered, and as a risk. And if something happens, how do we see the safety that's to be ensured is going to be a big factor in that in that particular scenario there.
Thank you, Amit. Thank you, Stuart. That's all of the questions we have so far. Is there anything else you wanted to add, Stuart or Amit, before we close out?
I think just on that previous question, a final word was that we're frequently asked by operators to conduct spares reviews or inventory reviews and identify that if the spares holdings are in compliance with what the manufacturer recommends. But sometimes within there is a gap that we're not looking at what the obsolescence issues are of what equipment is going to go out of service and how that is going to be addressed, and therefore the spares that they're holding, whilst they may be in accordance with the OEM's recommendations for the obsolete equipment, they may not be valid for the equipment that needs to replace it, and therefore it's a different problem.